afternoon to you, the audience, those who are virtual. Thank you, Informa Markets, for providing this opportunity. In fact, it is, I think, perhaps the first official platform where I'll be speaking on the policy regulations about circular economy since the announcement by the Government of India on a policy for mandatory recycling. Meaning now the solar panels or the solar PV modules by law have to be recycled as part of the e-waste. The policy was just announced. So I'll be but speaking more about why the need for a circular economy, how that's going to benefit, and keeping in line with the theme of this particular event, we are talking of net zero. So can I have the presentation? Yes. So that's already put. Circular economy profiting solar energy. Next. I have, I think, 10 minutes. That's what the counter is showing. So I was given about 30 minutes time. So, okay, fine. Now, the UNEP, the United Nations Environment Program, says that, you can see here, the world is facing a triple crisis of climate change, nature and biodiversity, and loss and pollution and waste, and all these three need to be addressed. Circular economy is the response that addresses all these crises, reducing the use of material, energy and preventing waste. Now this will be, the crux of the current presentation. Let's understand what's the difference between a linear economy, a recycling and a circular economy. Often, there is a confusion. Does recycling mean circular economy or vice versa? Or they are two different, or how do we understand? So, it's very simple to understand a linear economy. You extract the raw materials, you produce the good, as you can see here, you make it, you use it, and then you throw it as a complete waste. Simple as it is, right? That's a linear economy. Now, what the next step happened that perhaps there were technologies that evolved. Can we reuse these materials when they have attained the end of the life? Hence, the term recycling came in. And it's not new. Recycling has been practiced for ages in our country, other places as well, or maybe in other industries, I would put it. So what the recycling states is that you extract the raw materials, you make the product, you use it. Now once they have achieved end of life, maybe some of them can be recycled back, but you may not recover 100%, right? You make an attempt to recycle, so there will be some waste. For example, in the case of solar PV modules, as in the inaugural session, Shri Mishra ji mentioned to focus more on circular economy, which will be the future business. And he mentioned that 98% of the materials can be recycled. That's a fact, yes. So in the recycling, that 2% is what needs to be further addressed. Right? If 98% can be recovered, now let's understand also what the 98% that is recovered will be in the form of a secondary material. I mean, don't expect that if we are recovering the glass, we reproduce the solar glass. Yes, you can reproduce, but by going through a certain process. So that's recycling. Next we come to the circular economy. What in practice circular economy means, there is zero waste, right? Zero waste. That is, whatever we extract, we make, we produce, we use, we recycle and reuse 100%. So all the materials that are reclaimed can be reused. As I said, in the case of solar PV today, one challenge is, the polymer materials, which are your back sheets and your encapsulants. Today, there are some solutions, but the 100% recovery is a challenge. So that's the major difference, and that's what needs to be addressed. Now, this particular presentation will focus on the crystalline silicon module. Let's understand the material by weight. 70% is glass, about 18% is the aluminum frames, and maybe traces of aluminum used in the cabling, right, or the interconnections. Then we have the encapsulant as about roughly 5%, and the balanced solar cell, which contains a lot of metals like your silicon, the silver, the copper, the lead, the tin, etc., etc. So the glass and aluminum itself make up for the 88%. Now these are the materials that can be 100% recovered, right? So 88% we have addressed. The balance metals can also be recovered. There are technologies, yes, of course, as rightly said, because of lack of volumes, the economics are not working. When we come to India's potential target, now in the previous session we had India's target set as 500 gigawatt. I stand corrected. What we were given to understand that India had set a target of about 500 gigawatt. Solar would contribute roughly about 350 out of this. Imagine 350, 100,000 megawatt. If that is the magnitude of installation that is going to happen in India, how much waste we are going to generate. This is just an indicative graph of how much India has achieved and what's the projection until 2030 to achieve the 350 gigawatt, right? And assuming, let's say, a standard life of 20 years, some may take 30 years, fine, but typically, let's say, after 20 years, when the end of life will happen, how much raw material we will have. So let's see that. Here it's. Now, we are taking a bit of a conservative figure. Instead of 350, perhaps we may take about 300 gigawatt on a safer side, under regular basis, right? Not under optimistic or pessimistic we are going. So, by 2030, under the regular scenario, the demand for glass would be about 13 million tons, aluminum about 3.5 million tons, and solar cell about 1 million ton. That's the demand we have, as against 0.3 million glass, 0.1 million tons, and 30,000 tons consumed in 2015 when the real market picked up. So that's the volumes, a staggering jump we will have as far as the raw material is concerned. Now, availability of raw material, as of now, there is no panic button, but recycling and recovering, that is what is going to be the challenge for the future. Now, the question is, can we recycle and recover these metals or the materials and reuse them in the solar industry? Let's see the answer. So, if, let's understand, we leave this waste untreated, what happens? Right? What happens? The glass, the aluminum, major, they occupy about 88%. Yeah, fine. Okay, so what will happen? Here it's given. All accumulated materials, if they are unused, they will occupy, you see how much? By the year 2050, when we would have actually crossed the 20-year end of life of the last installation in 2030. How much? Can you see that? 300 million kilometers of line. Sorry, 1.5 billion kilometers of the tons of waste. You know, we are a cricket passionate country. This will roughly occupy about a 27 Eden Gardens cricket stadium just by piling these waste. Do we want our IPL to be closed? We can't afford. So let's have the solution to recover these. Now, there is a factor called as early loss, meaning perhaps the solar PV modules may not last 20 years, they may achieve end of life much before. Now, there could be various reasons which have been listed out. I won't go more into details. Perhaps some may go for repowering using a higher efficiency cells once they have recovered the investment. So maybe after 10 years when the warranties are over, some may be due to technical defects. So in that event, the quantum of waste material will increase. And there is a study undertaken by Irena which anticipates about 30% additional production will happen in India owing to quality of the components used. So when we are recycling and recovering these materials, fortunately all of the recovered materials will find use some way or the other, largely in the solar PV industry to make back the modules. I say largely, some may not, but largely it would be used. So I won't go into the depth of it due to paucity of time, as we are already behind schedule. Now, one of the major advantages what we are going to achieve is that if these modules are recycled, let's say, the standard production of 1 kilowatt peak of a glass, how much it requires energy, about 3100 kilowatt hour. The same if we use a recycled glass, it would be around 1200, a little above 1200 kilowatt hour. So we are talking of climate change, meaning we have addressed the carbon footprint, almost 60%. Same is the case of aluminium. If the aluminium frames are recovered and recycled, which is the easiest thing out of entire this recycling, look at the amount of energy that you save. Almost 90% of the energy is saved by using the recycled. So then why let it go waste? Why not recycle? At the current market scenario, the potential states in India for recycling is what have been listed. The darker colors have more potential compared to the lighter. So you can see largely the western and the southern states. These are the potential states that we have for recycling. Now, often that will come to a question, are we in a rat race? Are we in a rat race? Well, what happens, even if you are in a rat race, at the end of the race, you still remain a rat. So let's not think of the rat race, let's think of how we run and come in the race. These are some of the techniques of the delamination, because deframing is pretty easy. What the challenge is delaminating. Various permutation combinations are being used. I am seeing my timers is less, so I won't run through much of that. These are some of the examples how the recycling is happening outside India. Now, as I said, Government of India has already come out with the draft gazette on solar panel recycling, the solar module recycling, which is part of the EWaste, which is second after the European Union, which has Waste Electrical Electronics Equipment Law. So we are almost following. It is yet to be analyzed because it was released on the 19th of May. I was part of the task force that was set up. So these are some of the examples of the recycling. I am showing the images that are happening in Europe. Now, how circular economy will benefit India? I have brought out, even at the present level of 85% recovery, we can, from those 300 gigawatt, produce fresh 250 gigawatt peak modules. Here we are addressing Atmanirbhar. Why stretch our hands? Why do fresh mining? Why add to the carbon footprint? Right? With circular economy of the raw materials, then we can reproduce almost 300 gigawatt peak if we practice the circular economy. Right? I explained in the second slide the difference between recycling and circular economy. Circular economy states you recover everything, whatever you produce. So, if 300 gigawatts are produced, let's recover 300 gigawatt. A challenge for the entrepreneurs, for the numerous scientists or technocrats, the engineers to come up. We now are proposing that the extended producer responsibility be brought as a law, and it has been already made part of the law of the e-waste, meaning one who produces the solar PV modules. Now producer means one who manufacturers as well as those who are importing. Those who are manufacturing as well as those who are importing, all will have to take back these solar PV modules when they have attained the end of the life. Now after you take back, you have to also safely dispose, meaning you will have to recycle. A good thought would be, to form a producer responsibility organization or an organization that will collectively take care and manage the waste of all the producers as well as the importers, right? One single agency that is going to take care. Because you see, in India we have multiple number of smaller manufacturers as well. Now for them it will be an additional activity, additional expense. I'm sure, for the retrospective modules that were made, they would have never incorporated the cost. For EPR, you have to take back the modules, which will cost, you have to recycle, which will cost. Of course, henceforth onwards now there will be a cost built, but an agency or a body that is going to collectively manage. And this model has been successful in Europe. It's called as the Producer Responsibility Organization. Here is the draft gazette of the e-waste. I'm just giving a snapshot of the law under which it has come. Right? Now, what it states is that once you have attained the end of the life, in the first year, you are given a relaxation. 60% of your waste will have to be recycled. So let's say, as an example, my modules were produced in 2015. So in 2025, I will have to recycle at least 60% of them. Now, I'm just quoting this as an example. Don't take 20 years because the life of the module is yet to be defined under this law. So I'm just quoting as an example. Then, if it's 2016, by 2026, you will have to recycle 70%. And the subsequent year, 80%. That's what, in short, this particular draft gazette means as a snapshot. We try out all kinds of jugaad. These are called as the Indian terminology. So, practicing circular economy is nothing new in our country. Do you all agree? We have been doing this, and let's pat on our back, we all are smart people. So we can even achieve in the solar PV, circular economy, if it is bought. Nothing really to fear on it, no challenges. We will achieve it. You just tell, aap batao, hum kar denge, that's the way. I say, it's like this, waste is not a waste until we waste it. So why have the word waste? Right? One profits most who serves the waste. This could probably be the tagline, I hope so, for the RenewX in the coming events. When from net zero, they may probably turn to one who profits most, who serves waste. Probably there could be events just on solar waste. I think so. In nature, there is nothing as such waste. Right? In nature, nothing is wasted. Everything is recycled. I'll just give a classic case study of my recent experience in Europe. This is a shoe made from a single polymer material. A single polymer material. It's a sports shoe, right? So they don't use multiple type of materials for the sole, for the inner sole, for the laces or whatever you may say, blah blah. This is just made from one single piece of a polymer material, and once the shoe attains end of life, this can be recycled back to the original material, right? Once it's recycled, it regains its original form. That's why if you see at the background, they have addressed circularity. No waste, nothing, we don't dump anything. Finally, the recommendations, I would put it. Government now, what we need to really do is invite R&D proposals to develop indigenous. Let's be Atmanirbhar in developing indigenous technologies for recycling, rather than being more dependent on the other countries who already have the solution. Then we need to actually study the electrical performance of the modules for the 5-year and 10-year period, because there is this greater chance that Indian PV modules may achieve faster end of life owing to the quality of the raw materials used. Now, there may be questions, you see many challenge. Solar PV technology per se is not 100% carbon neutral. Let me tell you, there is an embodied energy. You require a lot of energy to make the polysilicon, then the wafers from the ingots, the aluminium, the glass, everything. But the net delivered energy is far, far more. We call that as an embodied energy. So it's a positive energy, meaning it's not creating zero carbon footprint, but then it's not creating substantial. Now, why this will be required to calculate the carbon footprint is actually for producing a module and taking a given life, assuming whether it's 5 years, 10 years, 20 years or 30 years, what's the carbon footprint we are avoiding vis-a-vis the carbon footprint that was created in the production. So this also a study will need to be done, and I think that is there already in the agenda of the task force which was constituted. And finally, a pan-India solar waste management organization. This will be very much required. I end my presentation here with my details. It was wonderful having you. I'll just conclude, it reminds me of, a very classical song, if we go. For those who have been ages long hearing to our old songs, कि कितना बदल गया इंसान, सूरज ना बदली चांद ना बदला, कि कितना बदल गया इंसान, देख तेरे संसार की हालत क्या हो गई भगवान, कि कितना बदल गया इंसान. Kavi Pradeep had written this song. We are following that path. Let's hope that we protect our planet, our beautiful earth. Thank you very much.